So welcome everyone to today's lecture, and we would basically continue today's lecture from where we stopped from last class. Due to the fact that we have taken so much time to talk about, the introductions and the GitHub issues and all of that, I would rather not ask anyone to talk about what we spoke about yesterday, what we did yesterday. So I'll just do the overview myself. So from yesterday's class, we were able to, first of all, install all the tools we need for our environment. And we started by talking about the Rust toolkit. We installed that. We then went on to install the Stellar CLI, and we also installed the WASM targets also. And these are the things we installed. And from that, we were able to see how to set up an account, especially for testnet on Stellar. Then after that, we started by initializing or creating an instance, and we were able to see what the structure of an instance of a project for Soroban looks like. We were able to see the library, the test file, and then we went on to talking about how this is more like a workspace pattern. And in Rust, when you think of workspace, it's a pattern that allows you to write a robust implementation. So it necessarily has nothing to do with Soroban. It's a pattern in Rust for you when you want to have so many Rust files and folders that intertwine and work together. And so Soroban basically helped us already by creating this workspace pattern. And so included in the members of this workspace pattern is the contract, and this star includes every other folder inside of this contract. So we see the contract, and the only folder we have now in the contract is this one, Hello World. They could add more folders, and each of these folders would have their source file, their source folder, and based on how you want it. So this was more like talking about the structure for the folder. Why am I talking about this structure? The truth is that uh, it is important that you understand how to organize your files in Rust. If not, you would have a whole lot of compiler error, because each files have to be able to read certain files that they need. And if you do not structure your files well, you won't have access to it, basically. Moving on to the major implementation, we also made mention that the no STD indicates that we are not using anything from the Rust standard library. Then this use is literally a way to import dependencies that we need. So we are importing from the Soroban SDK, and if you go to your cargo, you would see the dependency, Soroban SDK. It's what we are using. And this workspace equals true means that for every folder that you create, you can basically use this Soroban SDK dependency inside of it. So inside of the Soroban SDK, we are importing this contract macro, this contract implement, this vec, the env, that's the environment, the string, and vec, which is vector basically. So we know string, vec, all of these come from raw standard library, but we are not using the ones from raw standard library. Rather, we are using the one from Soroban SDK itself. So to declare a contract, we mentioned that you need to create a struct, name the contract, whatever you want to name it, and then implement that struct. If you can remember from our class on structures, that's struct. Oh, I'm so sorry. Okay. If you can remember our class on structure, that's struct. For that particular class, we spoke about a single struct, a struct with no field element, and this is an example of that. And so this example goes on to show how important even single structs without having elements can be used. And in this case, we have the hello world implemented, and all of the functions that would be added to this hello world will be the methods you can call in the smart contract. Next up, we went to looking at how the test works. We were able to create the contract ID, the client, and we understood that this hello world is literally coming from this struct. The moment you change this, you have to change it here. And so the client is also what you would use to interact with the methods that come from this contract. Next up is using the assert equal. The assert equal is basically a testing macro in Rust. And this particular macro asserts that this is equal to this. So you can see the comma between it. So you can say this is equal to what? This. You can also use assert. There's another one called assert. Assert is a situation for assert. You definitely have to use equal to. So you say assert that the word is what? Is equal to this. This is another macro you could use. So there are different macros you can basically use when you are working with what? You see, this is assert nil. For the assert nil, you won't use this, you would use comma. So you can assert that this is not equal to this. And that is another one you can basically use for your what? For your test. Next on, we moved on to talking about how to deploy. And after running the test, we saw, okay, the test was working fine. And I even mentioned from last class that this test that we are writing on top of it is to signify that this particular function is part of the test. And I also show that if you run a function that does not have this on top of it, it will not be included in the test. Now, going to the terminal, we were able to see how to deploy a contract. And yesterday, we in fact deployed this particular contract yesterday. And so today, from yesterday, in fact, before we move on to today, from yesterday, I was able to also show us what I was talking about when I talk about the WASM hash that is being deployed. The WASM hash you get when you deploy the WASM bytecode. Now, here is the link, is the directory to our WASM that we were deploying inside of this target, this release, this hello world.wasm. Like I mentioned from the classes, from the slide classes, this is the wasm we are deploying. And so when we deploy that wasm, we get an hash. And so this is the hash we get. Can we see? So now, if you notice something that is happening here, you will notice that this is saying using wasm hash 8A512. What do you notice from this? This is to state that the contract understands that a particular WASM bytecode has been deployed before. And so why are we trying to deploy a new WASM when one has been deployed before? So it checked it. And so for that reason, it skipped the what? The installation of the WASM, because the WASM has already what? Has already been installed. And from this, it was able to create another instance of our contract for us using the unique identifier of the WASM that was uploaded before, as you can see. And then this was the transaction hash, and eventually it was deployed, and we got what? The contract ID for our new smart contract that has been deployed. How beautiful do you think that is for you to ensure that, oh, a contract has been deployed, this was At what point did you lost me though, please? Hello, can everyone hear me?
Yeah, we can.
Yeah,
At what point did you lose me though?
I think when you're still talking about the wasm.
Okay, great, great, great. Let me share my screen again. Okay. So I was still talking about the WASM, and here it is. So at this particular point, the WASM has been deployed, but because it has been deployed already, it is using the WASM hash that has already been deployed. It is not using this one. It is not trying to deploy a new one. Why? Because it's literally a waste of space. And this implementation, as I was talking about, really has nothing to do with us because it's an implementation that was implemented in the Stellar core. And so this is a great one to make the Stellar client lighter, basically. So moving on to what we have today. Today, we are going to be implementing something different. Now, due to the fact that everything we looked at here, we were not the one that write it. I mean, if you create an instance of a new contract, all that happens is what? Is this. You get this instance immediately. And so for that reason, all we'll be doing, because when you initiate a new instance, you basically have to change all of these too if you want to use it. You get. So what we'll be doing from today's class is we'll be changing all of these and we'll be creating an implementation of a library. So what are those things we'll be creating? First of all, we will create a library. Now, like I've always made mention of, whenever you want to build something, the most important thing is your architecture. But in this case, what we are trying to build is not something that is so big, it's very light. So what in our case would replace the architecture would basically be a list of what our functionalities would look like. So we can begin thinking. So we want to build a library. And in the library, we want us to be able to add book to the library, add book to the library. Then the next thing we also want for this is we want to be able to remove book from the library. We want to be able to remove book from the library. Then next, we want to be able to find certain book in the library. And next, the next thing we want to do is we want to list the books in the library. Also, from that library, we want to be able to count all the books. We want a function that will give us all the numbers of book in the library. So this particular smart contract we want to do is a very simple smart contract. What is the aim of this smart contract? The aim of this smart contract is for us to understand certain principles. That principle is based on the 4 things I mentioned from yesterday's class. What are those things? First, storing data, understanding how to store data in a smart contract. Second, getting the stored data from the smart contract. Notice that these are the goals of this particular smart contract you are building. Now, if you are able to understand this fundamental, it is very, very easy for you to build any smart contract, basically. So the next thing is what? The data type. The data type. And lastly, we want to think of the business logic. What is business logic? Business logic is basically the implementation logic. How are you able to, add 1+1 to make 2 to add and store? What are those things you are implementing to, because you are not literally creating just a function to, push and get. Now, your smart contract could do different things. It could be that it's calculating the profit, the gain, it's calculating a percentage. That is business logic. You can think of any implementation. That is business logic. So these particular 4 things, when you are writing a smart contract, you have to have it at the back of your mind. It's the fundamentals of any smart contract. Now, after you now understand this very well, now when I'm saying any smart contract, I'm talking about Solidity, Soroban, Inc., any smart contract you can think of. This is the fundamentals. When you want to learn that new smart contract, just understand, how do you store data? How do you get data? How do you create data types? And how does the business logic in a smart contract works? So these are the fundamentals first. Okay, there's a question. Yes, yes, as time goes on. But first of all, we want to understand that that would be on a different scope. But yes, if the time permits for this whole lecture, then we are going to look at it. We are going to look at it and we are going to explore it, because now when you want to think about that particular implementation for that kind of borderless payment, we're now thinking of anchors, implementing anchors in Stellar. And that is completely different from writing your Soroban smart contract. Although you can write a Soroban smart contract to integrate with it. But for now, we want to focus on the Soroban smart contract. And after we focus on the Soroban smart contract, when we have detailed understanding for this, we can then explore and go further. I hope that is gotten. So what are the things we need from this smart contract we are trying to build? The smart contract we are trying to build is a simple library smart contract. You know, when you go to a library, you can add a library, you can store a book in the library, you can get, that is to borrow a book from the library. You might try to find a book. Now, libraries have some sort of code base you use to find a book, if it's available or not. You can find. You can also list all the books in the library. You can count the book. All of this, we want to implement it as a smart contract. And so implementing it would give us these ideas that I've just made mention of. So let's move on with the implementation. So the first thing we want to do, obviously, is that we want to change the contract name. We want to change it to library contracts. Let's change this to library contracts. I'm going to name it library contract. You could name it library, whatever you want to name it. Yeah. I'm going to do this. Now, notice that because I've done that, everything here would be throwing compiler error. So one thing I'll just do is to comment it out. So commenting it out is what I'll just do. Now, I don't need this hello method anymore because I want to start creating my own method. And yeah. So what's the first thing I want to create from here? The first thing I want to create from here is I want to create a data structure. Now notice this is under data types. I want to create a data structure of book. So what would be included in that data structure? I'll name it book. What would be included there? I would have the title. Now the title of the book, I'll keep it as symbol. This is also another data type. I'll keep it as symbol. Then another one I'll be adding is the author of the book. So I'll keep that also as symbol. Now, this symbol is just another data type that can serve as a key to your data. Now, for the year, let's add the year of publication. So let's say it's a U32. Yeah. So this is what my data type for the book would look like. Now, for this, I'm going to implement something to show or ensure that it's actually a contract type for me to convert it to a contract type. For that reason, I'm going to add this and include what? Contract type. Now, including it would basically means it will be added up here. Now, the next thing I want to do from this is for me to derive the bug, basically, because I mean, we want to be able to print out whatever the bug. We want to be able to print out whatever we get from this. So I'll just add the clone and the debug trait. So the next thing we'll be adding, let's think, what else do we need? Okay, we need to be able to list all the books. So that means we need a data structure that will hold list of all the books. Let's create another struct and name it library. Let's create another struct and name it library. And for it, we are going to have the books. And we are going to make it a vec of books. So it's going to be a vec of book. And yeah, so we're going to add this struct as a vector. So this is going to be a vector of books. And then we keep it inside this struct library. Now, we also need to make this a contract type because it's not the contract, it's just a type in the contract. And do we want to print this? Yeah. So let's just use clone. So let's not use the bug. Let's just leave it as clone. We don't want to print it. So let's think, is there any other thing we might probably need? So I think we also need a library key. So let's create a library key. We're going to make it library. Library, and no, I don't want it like this. I want it to be symbol too. I want it as symbol. And for this, I'm going to use the symbol macro and add library, basically. Okay. So at this particular point, is there any question based on these data structures we have created for what we want to work with? Are there any questions? Any questions? Okay. Since there are no questions, I would proceed then. Okay. So right now, since we've created the data structures we need, we are going to talk about something. Now, what we are going to talk about, because due to the fact that we did not have so much time, we could not talk about it when we were learning Rust. So I'm just going to use this as an opportunity to talk about it. Now, just like in Solidity, it's possible for you to implement an interface. Now, in that interface, you could inherit that interface. When you inherit that interface, what that means is that every single function selector that is in that particular interface must be implemented in the contract itself. We can actually do the same thing here. But to do the same thing, we are going to use something called traits. Now, we are going to use traits in Rust to implement this because traits in Rust literally allows us to create function selectors to do something like this. So that's exactly what we are going to do. So let's implement it here. So we are going to create a trait, make it public, call it traits, and we will call it library traits. Now, note that you can name it whatever you like. I'm just putting my own as library, basically, traits. I'm just adding the what it is behind it. So you can name it anything you want. So the first one is we want to have an initializer. So we name it initializer. You can think of the initializer as a constructor. So let's just name it initialize. Oh, I didn't spell that well. Initialize. Yeah. So for the initializer, it's going to be taking in the env, that's the environment, and it should not be returning anything. It should just take in the environment. Now, at the end of the day, we are just creating this trait. We really might not know everything that is needed, but creating this trait just shows that, okay, we want to ensure that we implement all of these things we have made mention of. Now, all of the things we have made mention of will be including all these things we found here. So let's add it. So the next one we have on this list is book. think of that initialize as a constructor. So we're going to put add book, and we're going to have env as type env, and then we are going to have the title of the book. We can pass it in. It said it's a symbol. Then the author of the book. We also said that was a symbol, right? And then they said the year for the book, a U32. Good. Now, the next thing would be a function to remove the book. So we name it remove book. So we would have it as env, that's the environment. So we are passing that in so that we can have access to the environment itself. Now, if you talk about the environment, I'm sure we already understand that it includes the host. And we know what the host is basically from our previous classes. Now, we want to remove a book by the title. So using the title, we should remove this book from this vector. We're going to use the title of the book to remove the book. We could also think of using the author of the book. For me, I'm just going to use the title of the book to remove it because a book might have the same author. Like 3 books could have the same author, but if you remove the book by the title, I mean, it makes sense. The next thing we want to do is we want to also find book. So we would literally be finding the book with the title too. Yeah. Now, if you find the book, we want to return the data of the book. So it's going to be an option of book. Now, the next thing we want to do is, based on this, we want to list our book, right? So we're going to say list what? List books. And then we have env and env. So it's going to also return a vector of the book. So listing the book should return the vector of the books, right? And then the last function we want to implement is to count all the books in the library, right? So count the books in the library. So we would have the env and env, and then we want to return it as a U32, right? And so, yeah, now we have it. So what we have just done here is we have created more like an interface. In this case, it's a trait basically that allows us or that guides us to knowing the functions we have to implement in our code, in our contract, basically. And so with this, we are going to implement everything that is here. So if we don't implement everything that is there, we know there's a problem. What are the advantages of doing this? The advantage of doing this is that you are ensured that all the property of a particular contract is completed. For example, let's say you have a token standard that you want to implement. Now, you don't want to use already verified token standards. Rather, you want to implement your own token. But then you want to ensure that all the functionalities in the original token standard is involved here. Now, what would you do? You would then create an interface of all the function selectors for this, and then it includes all of these function selectors, and you inherit it. When you do that, it gives you the opportunity to ensure or enforce implementing all the functionalities in that interface. So you can think of this library trait we've just created in that manner. So at this particular point, is there anybody that have any question based on what we have just done or what we have just spoken about? Any question? Okay. So the next thing we'll be implementing is, okay. Who mentioned they asked a question?
I don't know how to pronounce his name. Ntiro?
Perfect. Yes, Tiro.
Okay. You can ask your question.
Awesome. So I've got a bunch of questions. So I guess maybe it's a skill issue, but what's the difference between crates and modules in Rust and by extension in Soroban? That's the first one. The second one is can you have crates that do computations off chain and then feed the smart contract? And third and last is unsafe code allowed in Soroban as well?
So, my brain didn't catch all the questions at once. So why don't you ask the first one, we answer it, then you ask the next one, we answer it, and on like that.
Also, well, no worries. Yeah, so the first one is what's the difference between crates and modules in Rust and by extension in Soroban?
Okay. Now, in Rust, when you create a module, it's literally more like a folder. So you can have more like something like, let's create new. You have a mod.rs, and then this mod.rs, inside of it, you can have so many other files in it that links up to this mod.rs. And then this mod.rs can then be used inside of the library. Now, a crate, you can think of a crate as a package you get. Now, when I'm sure you're familiar with JavaScript, TypeScript. Now you install dependencies. So the way you would push a package to npm is the same way you talk about crates. So you can think of them as dependencies, as libraries that are reusable, that are sent to crate.io, so other people can basically reuse it.
Okay, perfect. So as a meta conversation on that, it's modules can be a subset of a crate as well.
Yes, yes, definitely, definitely, definitely. Inside of a crate, you can have so many modules inside of it. Yes.
Oh, awesome. Okay, the second one is can you have crates that do off chain computations and then feed them onto the smart contract?
Definitely. Now, when you're talking about that, I'm sure you're starting to think of on ramp and off ramp. When you're thinking of having computations that feeds that feeds on chain, and yeah, it's possible. It's possible. Now, this is based on whatever implementation you are trying to think of. Now, if you talk about this, you might start thinking of implementations coming from something like oracles that work. And in the EVM background, you can think of oracles from people like Chainlink. So if you're thinking of creating something like that, yeah, definitely it's possible. Although it's not so available like it is when you think of it in the EVM background, because Soroban is managed by Stellar basically, and for the EVM background, you have so many chains that are basically writing their smart contract in Solidity. And it's so easy when the community is even bigger, for creating implementations of this sort. Does that answer your question?
Yes, perfectly. And the last but not least is, all of this non-standard library talk has me thinking about if unsafe Rust is able to be used in Soroban as well.
No.
With a lot of emphasis on the no, 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 no,
Yeah,
no.
there is, because in fact, if you're writing a normal Rust program without having to write a smart contract, it is always advised to think of it twice before you implement no save, because you are literally opening up your code for vulnerabilities. Now, if you use no save, you are sure that what you are using no save for is reasonable and important. You get now, talk less of a smart contract whereby we are trying to calculate every single computation that is happening in the smart contract. So it's just not wise to think of it at all. So let's not use it at all.
Okay, thanks.
Yes, yes, yes. Thanks for the questions. Are there any other persons with questions? Okay. If there are no one with questions, then we would basically proceed with the implementation. So we know we are trying to implement the functionalities we've just listed here. So all we do first is we would first of all create the initializer. So
Sorry, for again clarification.
okay,
It is not advised, but it is possible to use no
on
save.
save, right? Now, for that, I have not personally used on save for Soroban smart contracts. Now, I cannot for sure tell you right now that it is not possible. I believe, I believe it is possible, but due to the fact that I have not used the unsave, because I never even thought of it to even want to think of using the unsave in Soroban smart contracts. So I cannot specifically tell you that it is not possible, but I would just advise not to use it, even if it is possible. But I'll get back and check out if it's possible to use it, and then tell you about it later on for the next class or so.
Okay, thank you very much.
Yes, yes, yes. So going to our implementation, we definitely want to implement the first method. But before we implement this first method, how then do we connect this straight to our implementation? So what to do here is we say implement the library contract forward for the library traits. Now, we will notice that immediately we have compiler error. Now, if you check your compiler error, what's it telling you? It told you that it expected a type, found a trait. Okay. Yeah, what's the error from here? It said it expected, oh my God, I just made a huge mistake. I would have asked this mistake as a question, but since I have not explained traits before, then there'll be no need for me to ask a question for it. So the error we should have now is different. So the error we should have now is that not all trait items are implemented. Now notice what was the mistake I did earlier. The mistake I did earlier was I was implementing this contract for the trait. Instead, what I was meant to do was to implement the trait for the contract. So now, what do we have here? We have all the contract, all the functionalities inside of the contract. We have to implement it here. So it is giving us as a compulsory thing for us to basically implement every single function that has been added here to the implementation. So for us, I think the first thing we want to do, what I personally like doing is for me to actually declare everything, and then I'll just add the to-do macro to it. So the first thing I want us to do is let's just declare the functions, and we would come back to all of the functions, but then we will add a to-do macro to it, so we would not have this compiler error. I do not really like seeing the red line in my code. So I'll just add it to do here. And the next one, I would have this. Let's just try to copy it. But when you're writing your code, don't try to copy it. It's always good when you write your code yourself, so it can basically engrave and help your brain muscles. So I'm just going to add a to-do macro here. Then I would add the next one. The next one is basically remove book. I'm going to add it here, and I would add the to-do macro. Okay, I think there's more like a comment or question. Oh, vibe coding. No, Okay, okay. Please, no one should vibe code right now because I know so many people are on the trend of vibe coding right now. So please, no vibe coding. Code it, and when you code it, it helps your brain. It helps your brain a lot. So please, no vibe coding. So the find book, we would add the to-do macro too. I'm sure we all remember what the to-do macro does. The to-do macro literally helps us keep the function without giving us a compiler issue, and you really don't have to think of the implementation yet. So the last one would be count, right? So yeah. And yeah. So do. So with this now, we notice that the compiler error is what? The compiler error is gone. So this literally helps us eliminate the compiler error because we have added all the functionalities that are meant to be in this smart contract. Now, the next thing for us is to basically start implementing what? This smart contract. So let's start with the implementation of the smart contract. So the first thing we want to do is to initialize the smart contract, right? To do that, we're going to create the library. We're going to say, let the library equals what? Equals library. So we are trying to initialize this library. Remember, this is the library we are trying to initialize, this one. So this library, what do we have inside of it? We have a vec of books. So we are going to create books, and we are just going to create a new vector. And it's going to basically be a vec of book. We're good. And we have this here. So for this vec of books, we would definitely need to add the env inside of it to help. Okay. So the next thing we want to do is we want to do env.storage because we now want to store what we have here. We are going to take the instance and then we're going to set it. We want to set this inside of what? Inside of the storage. So we're going to get the instance for the key. We created a key already, this library key. And so let's just use this key we created. So we're going to say reference the library key. And what then would the value be? The value would literally be a reference of this library, basically. So with this, we have basically initialized what? We have basically initialized this library. So initializing this library now means we have a key to a data. And what is the data? It's a struct library. And inside that struct, we have the field element books that is packed with a vector of what? Of books. Now, this is just my own implementation. Now, if we are asked to do this whole library contract, you could choose to do it in a completely different pattern, and that's also fine. But this is literally how I choose to do mine. You could choose to, use a mapping whereby you are mapping a library. You use ID for the library, for the books, and then you are mapping an ID to probably a struct of book. And so it's just the implementation you want to think of. You can think of it any way you like it, basically. There is no enforced pattern to, implementing this. There really is no enforced pattern. So the next thing we want to do is for us to implement this add library, add book. So to do that, we are basically going to also get the library. So we want to get the instance of that library first, and then we will then modify what is inside of that instance. Okay. Is there a chat? Is someone saying something? Is someone's hand up?
No, I was answering something.
Okay. Okay. So to implement the add book, we will then first of all get the library, and the data type is actually library, right? This one, this library. And then the next thing we want to do is we want to get it from storage, right? I want to see env.storage.instance.get. Now, this time around that we are trying to get, we are trying to get the book from the library. And then getting the book from the library would means we want to mutate it. So I'm going to ask a question concerning this. So what happens? So I'm going to try to get the library using the library key, no, the library key. And what should happen? We would not want to use unwrap, because if you use unwrap, from our previous class in Rust, I have explained a situation where it is important that we don't use unwrap. We think before we use unwrap, because when you unwrap something that is none, or you unwrap a result that is an error, you just get a panic and it just goes out of scope. So you don't always want to use unwrap. You want to handle the situation, or in this case, what we want to do is we would use unwrap or else. Now, in a situation whereby we found nothing, unwrap or else, we would use unwrap or else. And what's the else? We would create this. We create a little closure here. And in the closure, we are going to create a new library completely. So we are going to tell it to create a new library. And inside of the new library for the books, we are going to create a new vector. Let me expand this so everyone can see what I'm typing basically. I'm going to create a new vector. And inside of it, we are going to add the env. So this is what we are going to do, basically. So let me use cargo fmt and see. Good. So using cargo fmt literally helped us reformat this code, and we have it easier to see. So now, I did not do something that I should have done, and this is definitely going to affect us. What is that thing? Can anyone point out what I was meant to do that I'm not doing here, based on what I did here? Anyone? Can anyone point out what I meant to do that I did not do? No answer. Think of ownership. Can everyone still hear me? It's something very simple. I just want us to literally understand some of the things we have done in the past and for us to use it here. So what is that? Anyone? Since no one is talking, I will just answer my own questions. So what we are meant to do is to add the mute keyword. First of all, we want to understand that we are trying to mutate the state. And for this reason, we need to add the mute keyword when we are trying to mutate what is going on in this storage. Now we've gotten this library. We want to mutate what is inside of it. So without using this mute, it's not possible for us to mutate it. And so that's what we do. So the next thing we want to do is then to say library dot what? Dot books dot what? Dot push. Now we are going to use push back because we are trying to push from the back. Now notice, when you are talking about this pushback, Notice that it's coming from the Soroban SDK. Now, if you are talking about pushing a value inside a vector in Rust, you would just use push. But this time, you are using either push back or push front, like as we can see from here. So what it does is to push it to the back of the last item in the vector. Now, so what are we pushing there? We are pushing a completely new book, right? So this book would have a title, an author, and a year. So we're going to push back the title, the author, and lastly, what? The year. So this is what we are going to use for it. So after doing this, okay, then it's asked, why are we mutating the library? Please explain. The function we are trying to create here is to add a book. Now we are adding a book to this library. And so that means to add a book to the library means we are changing a storage. And you cannot mutate a particular value that is what? That is immutable. And pushing a book would mean we are adding more data to the value. And so that means the value is mutating. And we understand from the rule of ownership in Rust that if you do not add this mute keyword, every single value that is created literally is an immutable value. So that's why we use the mute keyword. So after using the mute keyword, the next thing is now to push this library, since we have mutated this library, is to push this library inside of what? Inside of the storage bag. So we say env.storage.instance dot what? Dot set. And then we use the key, which is this. That's the library key. And then what is the value we are trying to set? The value we are trying to set is what? Is library. And then we what? We set it. And we can proudly now say that we have what? We have implemented our what? Our add book function. It's as easy as that. Notice that the major thing I'm trying to portray, because this smart contract is a very simple smart contract. The major thing I'm trying to portray to us is understanding how to set and get in your smart contract, basically. Okay, does someone have a new question? Is someone asking a question?
No, I'm just responding to their questions. Sorry. Just assume.
Okay.
Yeah, I'll let you know if there's a question. Okay.
Is it possible for you to let me view the chat section? I noticed this chat section includes just the host and the panelist. It's easier for communication, so I don't stop at the middle of the classes.
Sure.
Yeah. So basically, from what I was saying is that the storage, literally, we need to understand how to set to the storage and how to get from the storage, because that's literally what smart contracts are all about. It's just then adding the business logic that makes it, for you to try to start understanding what's going on. In fact, in programming in general, it's all about setting and getting. The business logic is what now makes it, extensive. The business logic is now what adds where you want to try to optimize. Now that's what's making your code more complicated at the end of the day. So you have to understand this fundamental, and this fundamental is what I am pushing for us to get. And that's why I created something easy like this. So this is how we come to the end of our class for today. Tomorrow we would continue from where we stopped, where we would what? Implement the remove, the find book, list book, and we would also implement the test for this. Then if we want, if our time permits, we would also deploy the contract and even what? Interact with our deployed contracts. So at this particular point, I thank everyone so much for the time taken. But if there are any questions, you can still ask. But notwithstanding, I still can't say anything here, IJ. Okay. So if there are any questions, you can use the raise hand button and ask. But if there are no questions, this is where our class for today will be coming to an end. Thank you very much, everyone. And okay, Dennis.
Yeah, could you pull up the code for a moment? So correct me if I'm wrong.
Okay.
Is this library key, is it a unique identifier?
Is what?
Is it a unique identifier for a book?
Okay, you mean for this library key?
Yes.
Now, you can think of the definition of unique identifier in essence is just an ID that you can use to locate a particular item. You get? Now,
Mhm.
what I'm doing here is that I am setting data. Yeah. Now, when you are building your smart contract could grow so big that you could have so many data keys. And so this library key, in this case, you can think of it as a unique identifier for what? To get this data you are storing. Because in a smart contract that is so big, you will definitely have the key, probably the smart contract have admins, the smart contract have balances, the smart contract have users. You can have a key to all of these. And in that case, the data structure you might be using for that key might not be this symbol. It could be an enum of keys. You understand? So it could
Yeah.
grow as big as that. And in that case, that enum, you can think of it as a unique identifier. You understand? And your implementation could keep growing because now there are some cases whereby you might now start thinking of how do we implement a mapping? How do we implement a 2D mapping? You understand? So all of that comes from how you implement all of these keys because for us to talk about mappings, you need a key to a mapping. So, and now if you talk of 2D mapping, you need a key to the mapping. You understand? So just think of it. They are unique identifiers, obviously. But when you mentioned unique identifier, what came to my mind was this unique identifier here. Because like I mentioned from a previous class that when you push a WASM bytecode, a unique identifier is generated for you. So yeah, you can think of it too. That was what was literally in my mind. But now when you spoke of this key, yes, this is also, it's a unique identifier basically to identify because if imagine we want to keep some other things in this contract, we then have to what? Create another key for it. And like I said, it could be an enum of keys. So that's just literally it. Does that answer your question?
All good.
Anyone with any questions?